Okay, hello everyone. Everyone can see the screen okay?
Yep, all good.
Okay, good. Okay, thank you. So I will give a brief project update on this project entitled Long-Term Hydrological Dynamics of Canada's largest watershed, the Mackenzie River Basin. The Mackenzie River Basin is one of the world's largest and most important freshwater ecosystems. Located in northwestern Canada, this is a region where climate change is disproportionately affecting ecosystems. And this project seeks to explore the question, how will climate change affect water quantity and quality in the Mackenzie River Basin? Our project will specifically examine long-term trends and cycles to develop predictive eco-hydrological models. This is a large collaborative project funded by GSC's Environmental Geoscience program, as well as an URTICNet grant, a NERC grant to the collaborator Leon Clark in the UK, Polar Continental Shelf Project logistical support, and substantial in-kind contributions from the Gwich'in Renewable Resources Board and the Gwich'in Tribal Council, Department of Cultural Heritage. Collaborators had come from across the GSC and NRCan, as well as external collaborators in national and international universities, Indigenous communities, and the government of the Northwest Territories. And this project is supporting 2 PhD students, a postdoctorate fellow, and 2 MSc students. So our progress to date is as follows. We've collected 11 peat cores, as well as 100 vegetation samples and shallow boreholes to collect depth to water table measurements from 8 sites within the Gwich'in settlement area of the Northwest Territories. We have analyzed most of these samples for Hawk pyrolysis, mercury analysis, elemental geochemistry, age dating, light stable isotopes, and paleontological analyses, including testate amoeba, pollen spores, charcoal, and plant remains. Parallel to this Western science aspect of the project is a traditional knowledge study. This is based on synthesis of previously documented knowledge related to water levels in the Gwich'in settlement area, including a synthesis of semi-structured interviews exploring hydrological dynamics in the Gwich'in settlement area, and a compilation of the Department of Cultural Heritage archives for information on changing water level, as well as the cultural significance to people living in the Gwich'in settlement area. And all of this data, once collected, will be amalgamated to reconstruct depth to water table, fire and vegetation history, chemical change, hydrological change, and synoptic scale climate patterns over millennia that may drive future water quantity and quality change in the river basin. So I'll just show some highlights from the field work. This is a map of the collection of the peat cores. 2 were collected from outside of the GSA, which is shown in yellow here. These are the 2 collected from outside, and the rest were collected from within the GSA. Only 8 of these are being used for study, and of these 4 MAC cores are being used for detailed study because these were collected with a purpose-built titanium coring device. So they are the highest quality cores. And then here are some photos of the 4 MAC sites. The fieldwork was conducted by the Gwich'in Renewable Resources Board in 2020 within the GSA. Here are some photos of the collection of the cores and the coring device and the core themselves on the right. As I said, these were collected by the Gwich'in Renewable Resources Board in 2020. And on the right is the subsampling protocol that's been devised by the Swamp Laboratory at the University of Alberta. And the MAC cores are being sliced at 1 centimeter intervals for the various analyses I outlined previously. Of the 4 MAC cores, only the MAC S3 peatland is ombotrophic and has been throughout its history. And this environment is ideal for reconstruction of atmospheric metal accumulation and paleoclimatic reconstruction. The other sites received input from connected surface waters and/or groundwater. To date the cores, we used lead-210. We also used AMS radiocarbon dating. To date peat cores, using AMS radiocarbon dating, it's ideal to use plant macrofossils, and the species of the plant macrofossils must be known. So a number of samples were sieved for plant macrofossils. These macrofossils were identified. In total, 57 were submitted for AMS radiocarbon dating. The youngest basal date from the cores returned at about 214 calibrated years BP, and the oldest basal date was almost 5,000 calibrated years BP, and this was from the ombotrophic Mac S3 bog. So I'll just briefly go over some other highlights. A plain language summary is being translated into Gwich'in. This will be included in the GSC open file, which is in prep by my PhD student and Wynn at Carleton University. The Gwich'in Renewable Resources Board presented a plain language summary in both English and Gwich'in to the Regional Resource Council meetings in the communities of Inuvik, Fort McPherson, Aklavik, and Sigachik. And this document in both Gwich'in and English are available on the Aurora Research Institute website. John Crowley from the Canadian Geodetic Survey conducted gray satellite analysis for the Gwich'in settlement area and produced a time series from 2002 to 2021 that shows this region has experienced a reduction in water storage capacity over this time interval, especially pronounced since 2017. A master's student at the University of Victoria, Hannah Travers Smith, recently published a paper of her analysis on landside satellite imagery used to map interannual changes in over 5,000 lakes and ponds in the lower Mackenzie Plain between 1985 and 2020. They show an overall surface area decline in lakes of the study region, mostly in larger water bodies. In contrast, smaller lakes tended to increase in area over time, likely in response to increases in precipitation. Lakes in the region were impacted by wildfire, were more likely to decrease in area. This likely has something to do with permafrost in the area and highlights how important it is to understand wildfire history. We developed a portable extruder for subsampling of sediment cores developed for field use, and the device can be used to subsample lake sediments at 1 millimeter resolution should we choose to do so. And the project has supported 1 postdoctorate fellow, 2 PhDs, 2 MSc students, local Gwich'in youth and community members, and a staff member at the Gwich'in Tribal Council, Department of Cultural Heritage. And here is a list of outputs associated with those highlights, as well as some others for further reference, and my contact information. Thank you for your attention.